Okay, so this is a problem from the post-assessment in Mathematics Grade 10 textbook. Find P so that the numbers 7P plus 2, 5P plus 12, 2P minus 1 form an arithmetic sequence. So first, since this is an arithmetic sequence, so we need to consider that the distance, the difference between a sub 2 and a sub 1 is equal with the difference of a sub 3 and a sub 2. So we have d, let's call the first difference as d sub 1. We can call that one as d sub 1. The is equal to a sub 2 minus a sub 1. Then the a sub 2 is 5p plus 12 minus the a sub 1 is 7p plus 2. Remember, this is the a sub 1, a sub 2, and a sub 3. So d sub 1 is equal to 5p plus 12. Negative times 7p is negative 7p. Negative times 2 is negative 2. So that's distributive property of multiplication over addition. So we have d sub 1 is equal to 5p minus 7p is negative 2p. 12 minus 2 is positive 10. So our first difference would be negative 2p plus 10. Now we will have the second difference. So it would be, let's just call it d sub 2, wherein we have a sub 3 minus a sub 2. So d sub 2 is equal to a sub 3 is 2p minus 1, then minus quantity of 5p plus 12. Always remember, when subtracting with a binomial, you should always enclose it in a parenthesis, so the negative will be distributed to all the terms. Okay, so d sub 2 is equal to 2p minus 1, negative times 5p is negative 5p, negative times 12 is negative 12. So d sub 2 is equal to 2p minus 5p. So we have negative 3p. Negative 1 minus 12 is negative 13. So this is our d sub 2. So in order to continue, we will just erase this one so we can have space. Also this one. Okay. So we have d sub 1 is equal to negative 2p plus 10, and d sub 2 is equal to negative 3p minus 13. So we will now use the reflexive property, where since that this is an arithmetic sequence, so it's safe to assume that the d sub 1 and d sub 2 are equal. So we have the d sub 1 is equal to d sub 2. Then replace d sub 1 with negative 2p plus 10. So negative 2p plus 10 is equal to the d sub 2 replaced with negative 3p minus 13. So since negative 2p is greater than negative 3p, if p is positive, as long as p is positive, so this negative 3p will adjust. So we will have add positive 3p to eliminate negative 3p. The additive inverse of negative 3p is positive 3p. So since we added positive 3p in the right side, we will add positive 3p in the left side to maintain equality. So 3p minus 2p is 1p. But we don't need to write 1 as if the coefficient is 1. Then plus 10 is equal to negative 13, since negative 3p plus 3p is 0. 0p or 0. Then, in order to solve for the value of p, we will now add negative 10 both sides to eliminate the positive 10, because negative 10 is the additive inverse of positive 10. Since we added negative 10 on the left side, we will also add negative 10 on the left side. So 10 minus 10 is 0. So P is equal to negative 13 plus negative 10 is negative 23. That is the correct answer. So the correct answer would also be letter D. You can do the checking. You can actually do the checking by replacing P with negative 23. And if you do, it will result to an arithmetic sequence. Okay, let's have another example. What is the sum of infinite geometric series? 3 over 4 minus 9 over 16 plus 27 over 64 minus 81 over 256 plus up to infinity. So what we're going to do is write first the formula for this sum to infinity. So it is S is equal to A sub 1 over 1 minus R. So we'll know that the A sub 1 is equal to 3 over 4. And negative 9 and negative 9 over 16 is the A sub 2. 27 over 64 is the A sub 3. And negative 81 over 256 is the A sub 4. So we need to solve the ratio. Then we can be able to solve the sum to infinity. So the ratio is A sub 2 over A sub 1. In this case, you can also use A sub 3 divided by A sub 2 or A sub 4 divided by A sub 3. So here we will use just A sub 2 over A sub 1. So A sub 2 is negative 9 over 16 divided by A sub 1, 3 over 4. So we'll use the law of reciprocality. So negative 9 over 16, the law of reciprocality states that you just have to change the division or divide sign into, or division sign into multiplication. Then reciprocate the denominator, which is 3 over 4. So it becomes 4 over 3. So R is equal to, first we can do the cancellation property. Since this is just a one term, so we can use the cancellation property on 16 and 4. They are both divisible by 4. So 4 divided by 4, 1. 16 divided by 4 is 4. And 9 on 3 are also divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So it becomes negative 3. 3 times 1 is negative 3. And 4 times 1 is 4. So the R is equal to negative 3 over 4. So now we can be able to solve for the sum to infinity. So S is equal to A sub 1 is 3 over 4 over 1 minus negative 3 over 4 because R is negative 3 over 4. Then negative times negative is equal to positive. So it becomes 3 over 4 over 1 plus 3 over 4. Okay, I'll just erase this one. Then we have to solve this one first. So there are many ways to solve that one. One is 1 plus 3 over 4 is equal to, automatically the LCD would be 4. 4 times 1 is 4. 4 divided by 4 is 1 times 3 is 3. Then copy the positive sign, the plus sign operator. Then we have 4 plus 3 is 7. So it becomes 7 over 4. You can also have, so it becomes 7 over 4. You can also have this one. 1 plus 3 over 4. Just copy the denominator. So 1 becomes 4 over 4. Remember that 4 over 4 is still equal to 1. The purpose of that is so that we can be able to easily add the two numbers because they are now similar fractions. So 4 plus 3 is 7 over 4. So still the same. So we have S is equal to 3 over 4 plus 7 over 4. So by using the law of reciprocality, it becomes 3 over 4 times 4 over 7. So cancel, becomes 1. So 3 times 1 is 3. 1 times 7 is 7. So the final answer is 3 over 7. And that is letter D.